This meeting is being recorded.
In this next problem from Chapter 1, 1.8, we're asked to draw a structure of each of the following ions. So that's T here. That will tell us that we either gain an electron for all these negatively charged species here, or for the positively charged, that means that we've lost an electron. So in the end, we want to indicate which atom would possess the formal charge. So step 1 is draw the structure here. So I'm going to just draw out what we know would be the final product after doing valence electron count and doing a Lewis structure for this compound here. By the symmetry rule, kind of, we place boron in the middle. It's the most electronegative, so it would also go in the middle, and then we surround it with the 4 hydrogens. Boron is in group 3, so it normally would have 3 valence electrons to be neutral. So we'll do our calculation for boron's formal charge. 3 minus 1 electron from each of these 4 covalent bonds would show us that boron would have that -1 formal charge on the boron. So our second compound, we have nitrogen bonded to 2 hydrogens. And in order for nitrogen to have a full octet, we would know that our structure would end up like this after we did a valence electron count and did the Lewis structure. So we would see this compound here. And if we wanted to calculate the formal charge on nitrogen, we know that that's in group 5. So nitrogen's formal charge would be 5 minus, we have 4 valence electrons in the 2 lone pairs, and then plus the 2 one from each of these nitrogen-hydrogen bonds. So we end up with a formal charge of -1 that will go on the nitrogen. Each of the hydrogens, we know, only form 1 bond, so they're neutral. And then last but not least here, we would do again our Lewis structure for the C2H5 plus ion over here. And we would end up with something that looks like this, where this carbon has a full octet. This carbon over here only has 2 hydrogens in addition to the carbon bond. So this would end up bearing a positive +1 formal charge. And to check that, we know that carbon likes to form 4 bonds to be neutral. Carbon's in group 4, so 4 valence electrons minus 1, 2, 3 from the bonds here. 4 minus 3 gives us +1.